The Common Core authors emphasize coherence. When they discuss what they mean by this, they talk about how concepts flow over time and are connected to what occurs in previous grade levels and what follows from the work that we do with our students to subsequent grade levels. To kick off our PD module on operations and algebraic thinking at first grade, we're going to borrow this coherence perspective and consider what happened in kindergarten and how we can naturally extend that background to engage with first grade Common Core expectations. Let's begin by looking at what is new on the horizon in first grade so that we can examine the kindergarten competencies that will feed into these benchmarks. First, children are going to be exposed to new problem types, including one entirely new class of problems, compare problems. If you've been teaching this age level, I'm sure you've already seen how difficult compare problems are for children to comprehend and to solve. There is more attention to solving problems with unknowns in all positions. And finally, there is an emphasis on strategy development, moving children from level 1 strategies, which are primarily acting out, to level 2 and level 3 strategies. Now, this does not imply that children never use an acting out strategy after first grade. I like to even give my college-age students occasional problems that are considerably easier using an acting out strategy than trying to use operations, because I want them to recognize that they should always choose strategies based on what makes sense for the problem, rather than using a one-size-fits-all approach. Nevertheless, first grade is meant to be a time where strategies are actively evolving and developing. The progressions for K through 5 operations and algebraic thinking outlines OA competencies which incoming kindergarten students should have. These are good places to start at the beginning of first grade. The first item involves background experiences with early additive and subtractive situations. The second set of items and prerequisites for the Make 10 strategy. When we compare this list to the previous slide, we see that children's exposure to word problems will be extended, and also their capacity to use more advanced arithmetic strategies, such as the Make 10 strategy, which will also be developed in first grade. The print in this chart will likely be too small for you to see, but you can find this chart on page 88 in the Common Core State Standards for Mathematics. It is Table 1 in the glossary. The Common Core writing team also wrote a series of documents called progressions. These progressions outline the ways in which standards are connected to one another within grade levels and across grade levels. The progressions documents are a goldmine of information that elaborates on the Common Core standards. In this case, the authors of Common Core state in the progressions document that kindergarten children need experience with 4 of the 12 subtypes of problems shown here. I've outlined the 4 that kindergarten should have experienced in yellow. They involve joining 2 sets, separating a subset from a larger set, and considering 2 subgroups to figure out a total. This last type of problem is very similar to the one in which 2 sets are joined, except there's no joining action. For example, I have 3 red pencils and 2 blue pencils. How many pencils do I have? In this example, the pencils aren't really being joined or separated. They're just 2 different kinds. The 4th type of problem is called both addends unknown. You might be more familiar with the idea of brainstorming ways to decompose a number. The example here shown here reads, Grandma has 5 flowers. How many can she put in her red vase and how many in her blue vase? And essentially this calls on the children to think about 5 as a 2 and a 3, 3 and a 2, 1 and a 4, 4 and a 1, 5 and a 0, etc. Children in first grade will continue to work with these familiar problem types, but over the course of the year, you're going to be looking at supporting them in developing more sophisticated arithmetic strategies and extending the size of numbers that they work with to combinations up to 20. For your work on strategy development and your work on larger numbers, it's best to start that out with these 4 problem types, because those are the 4 problem types that kindergarten children already have the most experience with. So that makes them good tools for extending kindergarten knowledge. The remaining problems here are all going to happen sometime during the first grade year. They need to be able to work with all of these. And so that is the topic of this Common Core PD module. I earlier mentioned that there is a transition to occur during first grade from level 1 strategies to levels 2 and 3. We will be discussing these in greater detail next week, but here is a succinct overview. Level 1 strategy involves directly modeling a situation by representing every physical quantity, often with counters or fingers, and then acting out the situation. Level 2 strategies involve counting on. This is a natural extension from the direct modeling, but it involves abstracting one of the quantities and then moving forward or backward from that quantity without actually representing that quantity physically. The counting on strategy continues to be highly effective even for much older children and adults when the amount to be counted on is simply like 1 or 2 or maybe 3. However, it is just not a very efficient strategy for an expression like 8 plus 6. If you're going to be adding on more than 3 items, typically you need something more sophisticated in the way of a strategy, at least for the long haul. So we need to support our learners in developing even more sophisticated strategies by converting it to an easier problem. That's a level 3 strategy. Here in the example, I've shown a level 3 strategy for converting 9 plus 4 into an easier problem, 10 plus 3, and being able to use that to recognize that 9 plus 4 is 13. What I want to do now is take a level 3 strategy, make 10, which is the same strategy you saw on the previous slide, and I want to break it down and analyze what are the underlying competencies that are required. Of course, we can't expect children to be able to convert problems if they don't have the underlying competencies. And as it turns out, those underlying competencies are in the kindergarten Common Core. So we really need to access that knowledge and make sure it's being used by the students in order to try to develop these strategies. So quite a bit of knowledge and skill is required in putting a level 3 strategy to use. Let's use that Make 10 strategy with 8 plus 6 as an example. The first thing that happens here is that the 6 is decomposed into a 2 and a 4. You see that in the first step. This requires that a child can easily decompose a number in a variety of ways based on what makes sense for the problem. So I can actually decompose 6 in a number of ways. Children might not think of 2 and 4 first. They might think of 3 and 3 as a double, or 1 and 5 as another common combination for 6. So why 2 and 4? Well, I chose that decomposition because I'm thinking about a Make 10 strategy to turn the 8 into a 10. So what do I need to turn the 8 into a 10? I need a 2. So I broke the 6 into a 2 and a 4. So I needed to know how to decompose the 6, and I needed to know all my sums of 10 really well because I had to recognize at a glance that the other number I need if I have 8 is 2. So that's 2 pieces of information that I really need to draw on. And the third item is that I need to understand how all teen numbers are constructed so that when I generate 10 and 4, when I convert my 8 and 6 problem into 10 and 4, I need to be able to see instantly that that's 14. I just need to know how those numbers are composed. Now, while kindergarten children are not actually required to put all these competencies together into a level 3 strategy, these competencies themselves are to be developed in the kindergarten Common Core. I mentioned earlier that comparison problems are very difficult for many children. This means that we need to be very intentional about how they're introduced, and as much as possible we need to leverage their background knowledge of comparing to support them in comprehending and solving comparison problems. So let's take a look at the kind of comparing that kindergarten children are doing in the Common Core. The Kindergarten Counting and Cardinality Standard 6 deals with determining which group is larger, including using the language of greater than, less than, or equal to. And it indicates that they will have familiarity with matching and counting strategies. Let's take a look at what this looks like in the curriculum. I'm going to be using some images from Early Bird Kindergarten, which is in the Singapore Math series, available from www.singaporemath.com. These are the texts. In fact, this is the actual text that my daughter used when she was in kindergarten, so I've drawn from some of her books here. In this image, an introductory image, children are shown this picture and given the prompt that you see here to draw imaginary lines matching the soldiers with the horse or the prince with the princess. I want you to notice that the context is one that naturally lends itself to matching. We're not matching pencils and baseball bats, for example. We're matching things that you would really think to put together. Soldiers will need a horse, and to dance at the ball, each prince needs one princess. For children who struggle with matching at first grade, you might want to borrow some of these ideas, these contexts, to get them into thinking about matching as a natural strategy. And a couple of other contexts that I sometimes use involve birds and worms. Will any of the birds go hungry? Or children and coats. How many children will be cold? The curricula should also actively train children to speak the language of comparison. And often I try to transition from how many children will be cold to how many more children are there than coats. It's the second language is much more formal school language. The first one is much more accessing their regular language. So think about how to scale up their language and help them develop that formal comparative language over time. Here you see a sentence frame at the bottom that's being used to facilitate children's own capacity to speak the language of comparison. This is a few pages on from the original image. Children have already learned to identify which group has more and label it as more. They have also labeled which group is less. On the top of this page, you see the matching strategy suggested by the dotted lines. And the context is still one that makes sense to match. Cups with saucers, for example, straws with glasses. So there are matching items that would reasonably be matched. In the bottom images, children are further challenged to quantify the difference as well as labeling it more or less. So this steps up the challenge because now they have to combine two different kinds of knowledge in the same problem. They both have to think about whether one is more, which one's more and which one's less, and they have to quantify that difference. On this page, we see yet another step up in the challenge. The students are given arrangements that do not obviously suggest matching, such as the arrangements on the bottom, where you have a rectangular array. It's not quite as easy to draw those lines as it was when they were all set up in a linear fashion. Keep in mind that what we are seeing here is only the printed curriculum. These pages came out of the Singapore math, and the lessons all began with concrete experiences before they went into this work. So those concrete experiences gave children the opportunity to actually speak the language of comparison in process as they worked with actual objects. All right, as you go into a year then, where students must now take that background knowledge and apply it to solve, compare problems, it is essential that that background knowledge that they already have be employed. So consider ways in which your learners can gain some similar opportunities that lend themselves to the matching strategy without spending too much time going over and duplicating the kindergarten curriculum, which will really take time out of your first grade curriculum. Now, this can include drawing students' attention to just natural comparative situations that arise in the classroom. For example, as you are greeting the children in the morning, you could say, "Wow, look at how many pockets Joy has on her outfit today. I've got 5 beautiful pebbles I found yesterday. Do you think there are enough pockets for each that she could hold all the pebbles? Are there more pockets or pebbles? How many pockets would not have a pebble?" You can combine this with work on language. For example, you could say, "Why don't you look at our chart of compare sentences? Turn to your desk partner and use this chart to talk about Joy's pockets and the pebbles. Use the language of comparison." Another interesting thing you can draw from the curricular example I just gave was how it gradually increased in complexity. Look for ways to do that in your own work with comparison. Finally, consider how the use of context and images facilitated children's comprehension of comparison situations. Those could be useful tools, especially as you work with your struggling students and also as you think about how to ease into comparison in a fashion that will bring their background knowledge along for the ride. That concludes this section